Hey Cardinals, today we're going to talk about factoring, finding all of the possible factors for a given number. Remember that factors are numbers we use to multiply to get a number. All right, so when we're factoring, we want to find all of the numbers that can act as a factor for a given number. Two steps that we're going to follow, okay? Two steps, and we'll practice, all right? The first thing we're going to do is we identify our number. I want to find all the factors of 28. Okay, so the first thing I'm going to ask you to do is to create something called a factor tree. We're going to try to find all of the prime factors for that number. Remember, a prime number is a number that has only two factors, one times that number. All right, so we want to see if we can find all the prime factors of 28. All right, so what we have to start with are two factors that you know. Now, we don't want to use 1 in 28 because that'll put us back to 28 again. We already know we're going to have 1 in 28. Can you think of two numbers that will give you 28 when you multiply? Now, you got to know your facts because otherwise it's going to be really, really hard. So if you're not working on your facts, get out there and start working on them. Okay, got to know them. All right, what do we normally think of with 28? 4 times 7, right? 4 times 7. Now, when I write those two and I look at them, I want to ask myself, are they prime? Is 4 a prime number? It's not. Is 7 a prime number? It is. If it's prime, I'm going to circle it, okay? And I'm done with that 7 now because it's prime. I can leave that alone. 4, though, is not prime. I want to factor that again. I want to keep going until I get all prime numbers. What gives you 4? Okay, again, we don't want to use 4 and 1 because it puts us back to 4 again. What else gives me 4? 2 times 2. Now again, I ask myself, is 2 a prime number? It is. Is 2 a prime number? It is. And when I do that, now I have all prime numbers on the bottom. Okay, all primes. Now what I want to do is take all my primes that I have and list them in order from the smallest to the largest. Okay, so I've got a 2, and a 7. A 2, and a 7. We're done with the first step. I told you it was going to be a two-step problem. We've created our what I call a factor tree. It kind of comes down like a pine, like an evergreen tree. Okay. Now I want to take these factors and I want to create something called a factor rainbow. All right. Now on the outsides of my rainbow, I'm going to put the two factors that are furthest apart, and that's always going to be the numbers 1 and the number itself. So 1 times 28. They're always going to be the first one. 1 times 28. And now what I want to do is I want to count my way towards 28. What do I mean? I want to look and I want to say, all right, do I have a 2 in my list? Next number after 1 is going to be 2. Do I have a 2? I do have one, don't I? There it is. So I'm going to put a 2 here. Now, to find the number that goes on the other side of the rainbow, what matches with 2? Cover up one of the 2's and multiply the other two numbers together. So I'm going to cover this 2. And I'm going to do 2 times 7. What's 2 times 7? It's 14. So I'm going to put that on this side. And now I have 2 times 14 is 28. So far, 1 times 28, 2 times 14. And now I want to keep counting. What comes after 2? 3. Do I have a 3 in my list? No. Can I make one using multiplication? No, because the only thing that gives me 3 is 3 times 1. All right, after 3, do I have a 4 in my list? No. Can I make one using multiplication? Yes. 2 times 2 is 4. If I cover up the 2 times 2, what's left? Just the 7. 4 times 7 is my next set of factors. 4 times 7. Okay, after 4 comes 5. Do I have one? No. Can I make one? No. Do I have a 6? No. Can I make one? No. Now I can stop. Why? Because now I'm at the number 7, and I've already done these over here. So I've gone, here's 4, only thing in between is 5 and 6, and they are not factors. I can't make them, and now I'm at 7, so I'm finished. How many factors did 28 have? It had 6. 1 times 28, 2 times 14, 4 times 7. And now I'm finished. Those are the factors of 28. Okay? So, first we made the factor tree, found all our prime numbers, and then we counted our way to make our factor rainbow to find all the factors. Let's do another. We're gonna do a couple, don't worry. Okay, let's try, pardon me. Let's try 45. Let's try 45, all right? What do you know that gives you 45? Hopefully you know that that is 5 times 9. So we write 5 times 9. Now remember, we want to ask ourselves, is it prime, right? Is 5 a prime number? Does it just have the 2 factors? Yes, 5 is prime. Is 9 a prime number? No, 9 is not. We have more than 1 times 9. What gives you 9? 3 times 3. Okay? Is 3 prime? It is. Now I have all prime numbers listed, all primes. Now I'm going to list them in order. 3, 3, 5. 3, 3, and 5. We're done with our factor tree, and now we're going to make the factor rainbow. Always 1 in the number, 1 times 45. Those are the first 2 factors, okay? Now, looks like it's hard to see. All right, do I have a 2 in my list? Do I have a 2? No. Can I make one using multiplication? No. Do I have a 3 in my list? I do, right here. There's a 3, okay? Now, how do I find the other number? Cover the 3 and multiply the other numbers. 3 times 5. What's 3 times 5? It's 15. So 3 times 15 will equal 45. Do I have a 4 in my list? No. Do I have a 5 in, can I make a 4? Sorry, can I make one? No, I can't. Do I have a 5 in my list? Yes, I have one right here. Cover the 5, and now you have 3 times 3. What's 3 times 3? 9. Okay? So 5 times 9 is 45. All right. Do I have a 6? Can I make one? Be careful. You have to use multiplication. Don't say, oh yeah, 3 plus 3. No, it's got to be multiplication. I can't make a 6. Can I make a 7? Nope. Can I make an 8? No, again, using multiplication, not 5 plus 3. No, I can't make an 8. I can stop because now I'm at 9. I can't do 6, 7, or 8, and I can stop because I've gotten to the next number, 9. How many factors does 45 have? It has 6. 3 pairs. It has 6. 1, 3, 5, 9, 15, and 45 are all factors of 45. Okay? Let's do one more, because you can always rewind and watch it again. Let's do one more, okay? And then you can click on the link and practice it on your own. All right? Let's do the number. Let's see. Let's find a good one. Let's do the number. Let's do 42. Let's do the number 42. Okay? Now, think of your multiplication. And guys, if it's not coming to you right away, you have to work on your facts. That's your responsibility. There's no trick to learning facts. Sit down and work on flashcards. You got to know them. Got to know them. You just have to. All right, what gives you 42? 6 times 7. Okay? Now, ask yourself, is it prime? Is 6 a prime number? No. 2 times 3, right? Is 7 a prime number? Yes. Circle the 7. We said 6 was not prime. What gives you 6? 2 times 3. Is 2 prime? The only even prime number, right? Is 3 prime? Yes, 3 times 1. So now I've gotten I've gotten all prime numbers. 2, 3, 7. Okay? Now we're going to make our factor rainbow. 1 and 42. Is there a 2 in my list? There is, right here. Cover the 2, multiply the other numbers. 3 times 7. What's 3 times 7? 21. Okay, is there a 3 in the list? There is. Cover the 3, what do you multiply the other numbers? 2 times 7. What's 2 times 7? 14. So 3 times 14 is 42. Is there a 4 in the list? Nope. Is there a 5 in the list? Nope, and I can't make one. Is there a 6 in the list? No. Can I make one? Yeah. 2 times 3 is 6. Cover the 6, what do you have? 7. And I can stop because there's nothing between 6 and 7. I'm done. Okay? So this had 8 factors this time. It had 8 factors. Okay? All right. I'm going to do one more because we've had 3 numbers down here every time, and I want to see if I can't get a different set of numbers. All right, let's do the number 16. What gives you 16? 2 times 8. Is 2 prime? Yes. Is 8 prime? No. What gives you 8? 2 times 4. Is 2 prime? Yes. Is 4 prime? No. What gives you 4? 2 times 2. Prime and prime. So I've got these numbers now, all primes. 2, 2, 2, 2. I had to list 4 of them. I had to list all the numbers that I have circled. All right, here we go. 1 and 16. Okay. Do I have a 2 on my list? Do I have a 2? I have a lot of them. Cover up one of the 2's and multiply all the others. 2 times 2, 4. 4 times 2, 8. You have to multiply it all the way down. 2 times 8. Okay? Do I have a 3 in my list? No. Can I make one? Nope. Do I have a 4 in my list? No. Can I make one? Yes. 2 times 2 is 4. Okay? So I multiply the other numbers. Cover that up, multiply the other numbers. 2 times 2 is 4. It's 4 times 4. And I'm going to put this, the reason I don't want to put the 4 twice, the reason I don't put the 4 twice, because it's 4 times 4 like that, is because I don't want you to put 2 4's and say that this has 6 factors. It doesn't. It has 5. It only has 5. 1, 2, 4, 8, and 16. If you put the 4, you might say that it has 6 factors. This I'm going to write in the center. This is 4 times 4. And you can stop because we've gotten to the 4 and it's 4 times itself. So there's nothing past it. Those would be the 5 factors of 16. All right, so when you're factoring, you want to make your factor tree looking for what kind of numbers? Primes. You want to get them all prime and list them. And then you simply count your way. Do I have a 1? Do I have a 2? Do I have a 3? Do I have a 4? And count your way towards the bigger number. All right? Click on the link. There's a worksheet for you to practice on. Okay? Give it a try. Go back, rewind the video, watch it again. If you forget a step, you can watch it as many times as you need. Watch it with your parents and see if you can't work it through together. Just practice, 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 and that's how you get better at things. Keep working, Cardinals. I'm proud of you.